Okay, section 2, we are looking for patterns and linear functions. So we're going to try to identify and represent patterns that describe linear functions. So think about linear functions as a line, right? Things in the last section weren't always a line. They could go up and down and stay the same for a while. We're talking a line, a graph that looks like a line. Okay. So here's what we want you to write down for this. I would say start right here in a relationship between variables. The dependent variable changes. The independent variable changes in response to another variable, which is the independent. Okay. So the dependent depends on whatever the independent is. The values of the independent variable we call inputs, and the values of the dependent variable we call the outputs. So I would write down all of this.
Should you pretend people and make it less your message in the attendance office?
So in the diagram below, what is the relationship between the number of rectangles and the perimeter of the figure they form? Represent this relationship using a table, words, and an equation. All right, so the table is where we want to start. Okay? Start by drawing a table. And again, a table is essentially just a T-chart. Okay? We have our independent and we have our dependent. And our independent is what we're putting in. What we can control, the dependent will change depending on whatever our input is. And so we are going to put the number of rectangles. Okay, so this is going to be our number of rectangles, and this will be the perimeter. So you can think of this as our X and our Y. Okay, so whenever we have one rectangle, how big was our perimeter? So if you remember, perimeter is just going around the outside. So we had two number ones, right? So we had two of the number ones, and we had two of the number sixes. And that came out to be 2 times 1 is 2, 2 times 6 is 12, 2 plus 6 is 14. Okay. How about when we have two rectangles? Well, for two rectangles, we have two sides again, but each side here is 2. So we have two 2's, and notice this is what's changing. And then we have two 6's, which is 2 times 2 is 4, plus 2 times 6 is 12, that's 16. When we get into three rectangles again, we have two of these sides. That's what we're doing here, right? Two of these sides. So two of these sides, each one is 1, 2, 3. So we have two sides that are 3, the top and the bottom, plus two sides that are 6 long. This side and this side are 6 long each. And that gives us 6 plus 12, which is 18. We'll do one more. When we have 4 rectangles, again, we have two of these sides, which each one is 4. And we have two of these sides, which each one is 6. So we get 8 plus 12 is 20. Excuse me. So you see what's going on here is our equation are basically every time we add a rectangle, we're going up by approximately 2. So our next step is, how could you represent this relationship using words? What you want to do is, you want to multiply the number of rectangles in each figure by 2 to get the total length of the top and the bottom sides of the combined figure. Then you add both the 2 and the 6. Then you add 2 times 6, and that's the total length of the left and the right sides, which is the combined figure to get the entire perimeter. Okay? So again, what we're saying is you're taking 2 times however many rectangles there are, plus 2 times each side length. The equation, which is more important than in words, so our perimeter equals, and it almost always starts with y equals 2 times, notice how this number always went with however many rectangles there were. So when there was 1 rectangle, there was the number 1 in here. When there were 2 rectangles, there were a 2, and so on and so on. So it's 2 times however many rectangles there were. So 2 times x, plus we always added how much here? We always added 2 times 6. 2 times 6. We always added 12. Excuse me. And so now that is our equation. And then finally, in a graph form, here is our y-intercept, which is 12. 2, 4, 6, 8. Go up higher. So this is, we're going to say this is 4, this is 8, this is 12 right here. And we go up 2 and over 1. If all of these are by 2, this is 2, 4, 6, 8, 10. Up 2 and over 1, up 2 and over 1, or down 2 and over 1. Here is our line. All right. Anytime that you can describe that relationship where you pair like an input and an output, if there's only one output for each input, that's what's called a function. Okay. And anytime that function creates a non-vertical line or part of a non-vertical line, that's called a linear function. So I would put everything on this slide in your notes. So we're going to try this again. Describe the relationship using words, an equation, and a graph. So we already have the table. Okay. Describing that in words. So here's what happens is we started with a little memory card that has 512 megabytes of memory. And every time you take a photo, it takes a little bit off. Well, how much off? Let's find out. This was a difference of 3. This is a difference of 3. This is a difference of 3. We subtracted 3 each time. So it seems like every picture we take takes away 3 megabytes from our camera. So what we could say is basically the amount of memory left on the camera chip, or the memory card, I should say, I'm sorry, is equal to however many pictures we've taken times 3. So it's equal to 512 minus 3 times however many pictures we've taken. That's how you describe that in words. The equation would be y is going to equal 512, because that's what we're starting at, minus 3 times 512 minus 3 times however many pictures we've taken, and that's x. So again, now, we're used to y equals mx plus b, right? So all we have to do is flip this around, and that would become y equals negative 3x plus 512. Okay? And so now, this is a little bit harder to show on a graph because, you know, the numbers are so different, but we'll go 100, 2, 3, 4, 5, 600 is up here. So we're going to start right about there. We'll say that's about 512. And then every picture we take, we only go down about 3. So we're only going to go down a little bit there, a little bit there. You know what? We're going to redo that graph. Now, a much better way to show you that graph. Okay. Y equals 512 minus 3x. We're going to actually just do kind of a zoomed in. So we're going to say here's where 500 starts. That's 500. That's 505. That's 510. That's 512. And this is how many photos we've taken. So this is the megabytes left, and this is number of photos. So when we've taken 1 photo, 0 photos, we start at 512. Sorry, that should have been 515. Having a rough. Should have been 515 there, so 512 is about right here. When we take 1 photo, we're down to about 509. Another photo about 506. Another one about 503. Another one about 500, and so on and so on. And that is your graph. All right. All right. Sorry this video got a little bit long. It's a couple minutes longer than I'd like to keep it, but that's what we'll be working on tomorrow.